Okay. So coming to eigenvalues, we'll be finding eigenvalues using the shortcut that I have mentioned in the previous video. Then how do I find eigenvectors for the corresponding eigenvalues? How do I find the eigenvectors? I'll just show you how to find eigenvectors, how to find eigenvectors. Okay. Actually, the concept of eigenvalues and eigenvectors started with A of x is equal to lambda x. That means what? If I can express the matrix in terms of a scalar lambda using a vector x, then that vector would be called eigenvector, and that value which gets transformed from a matrix to a scalar would be called eigenvalue. Okay, so this is what I'll be using. I'll be using this to find the eigenvectors as well. What I will do is ax minus lambda x is equal to 0. I'll just rewrite, or in other words, I'll add and subtract um, I'll add and subtract minus lambda x from LHS and RHS. Okay. Yes. So what I will have will be I'll be taking out x common. I'll be having this equation. I'll be taking out x common, a minus lambda. I can't subtract a scalar from a matrix. So I'll be introducing the identity matrix I, which is similar to 1 in numbers. I'll be writing this equation. Using this equation, I'll be finding the vector x. It's a non-homogeneous equation, as all of us know. If I reduce this LHS matrix or resultant matrix, whatever is there, let us call this to be B. If I find the rank of B, I'll know what the values of. I'll be finding the rank of B using different methods. In the prescribed syllabus, we have echelon form to find the rank. So once I find the rank of B, I know what are the values of X. Okay. So here first I'll be doing for lambda 1 is equal to 5. Okay. So in the place of lambda, I'll be introducing 5. For lambda 1 is equal to 5, let x1 be the eigenvector. How does x1 look like? x1, x2, x3. Capital X1 looks like this. Let x1 be the eigenvector. Okay. So I'll rewrite this a minus 5i into x1 is equal to 0. x1, I'm in the process of finding x1. What's a? Minus 2, 2, minus 3. 2, 1, minus 6. Minus 1, minus 2, 0. I'm just writing for your information. But you can directly subtract 5 from all the diagonal elements. Okay, because it is 5, 0, 0. You will observe what exactly I'm talking. 0, 0, 5. And this whole thing is multiplied by the vector x1. This is equal to 0. So the resultant matrix would be a minus 5i would be what? Minus 2 minus 5 would be what? Minus 7, 2 and minus 3. No change in the other elements except the diagonal elements. 2, 1 minus 5 would be minus 4, minus 6. Minus 1, minus 2, 0 minus 5 would be minus 5. What is x1? It is x1, x2, x3, right? Simple. What I will do is I will reduce this to echelon form. RHS also I'll consider it to be a vector. I'll be reducing A to its to echelon form, for which what I will do, I can first interchange R1 and 3, that is one process, third row and the first row, that's one process, or otherwise I can directly do, okay, which is not a big problem, right? I'll be changing R1 and R3, okay, I can write in this notation as well, or R13 is also the same. So I'll be having minus 1, minus 2, minus 5. To second row, no change. Third row has become minus 7 to minus 3. Okay. Yeah. How do I find the rank? Minus 1 is the pivot or 1 is the pivot, whatever. So I'll be below the pivot, I should have zeros. So R2 would be what? R2 plus 2R1. Okay. And R3 would be what? R3 minus 7R1. Because both of them have same sign, I'll be using minus. Okay. Yeah. Always make it a point to do the elementary row operations in the rough. to avoid errors. Okay, second row is 2 minus 4 minus 6. First row would be what? Minus 2, minus 4 and minus 10. Okay, I'm just adding both of them because both of them have opposite sign. This is minus 8 and this is what? Minus 16. Okay, that would be my second row. I'll be using this equivalent symbol. The resultant matrix is equivalent. Equivalence means what? Obtaining a matrix after a certain row operations or column operations. Here I'm doing row operations, right? This is about the second row change, 0, minus 8 and minus 6. The third row changes minus 7, 2, minus 3. First row I'm multiplying with 7. So minus 7, minus 14 and minus 7 5s 35. Right? Okay. So I'm subtracting. So minus becomes plus, minus becomes plus, minus becomes plus. Minus 7 and plus 7 goes to 0. 2 and 14 goes to 16. And then 35 minus 3 would give me what? 32. Okay. Yes. So this is nothing but 0, 16 and 32. Okay. Yeah. One more operation. I want a 0 here. One more operation I'll perform and I'm done with it. Right? I can clearly see there's an 8. So I'll be multiplying 8 with 2 and adding it to 16. Or in other words, R3 would change to what? R3 plus 2R2. Okay. So it would be what? Minus 1, minus 2, minus 5. 0, minus 8, minus 16. 0. Anyways, this would be 0 as it is obvious. 32. And then 2 into 16 would be what? Again 32. I'm adding it. So again, this also would go to 0. x1, x2, x3. Okay, this is equal to 0, comma 0, 0, 0, 0. Okay, now you observe one small important thing here, please. What's the rank? The number of non-zeros would be the rank. So rank of the given matrix, whatever, let it be A or something, yeah, or B or whatever, as I have made a mention. Rank of B, the resultant matrix is what? 2. How many unknowns are there? 3 unknowns are there. N is equal to 3. The number of unknowns, guys, number of unknowns. There is a logic. What that logic is N minus R. R is what? Rank. N minus R unknowns we will be choosing. N is 3. Number of unknowns are 2. So one unknown I will be choosing here. We choose one unknown. We choose. Okay. Right. Now, see what I have. Minus x1. I write it in equation format. Minus x2 minus 5x3. Okay. Similarly, say is equal to 0. Minus 8x2 minus 16x3 is equal to 0. Or I can clearly see here x2 is equal to minus 2x3. How? Minus and minus goes off. This becomes plus. 8 also goes off. 8 2's. x2 would be what? Minus 2x3. I'll substitute the same relation in the first equation. Okay. Yeah. So what I'll be getting? Minus x1. In the place of x2, you replace minus 2x3. So here already there's a minus. Minus of minus would be plus. 2 into 2x3 would be 4x3 minus 5x3 is as it is. Okay. So what would be the resultant? Minus x1 is what I have. 4x3 minus 5x3 would be what? Minus x3. This is equal to 0. Or in other words, x1 is equal to minus x3 is what I have got. So x1 I have got in terms of x3. x2 also I have got in terms of x3. So as I have made a mention, one unknown I will be choosing. I will be choosing x3. It can be anything, guys. Here I am choosing x3 to be some k1. Okay. So what I will get? x1 to be what? Minus k1. x2 to be what? Minus 2k1. Right. So what would be my unknown vector? Capital X1 minus k1 minus 2k1 and k1. Okay. I can take out k1 common or minus k1 common. Anything is fine. If I take out k1 common, it is minus 1, minus 2 and 1. This would be my first eigenvector. Okay. Minus 1, minus 2 and 1 is my eigenvector. Now, let's see how we'll be finding for lambda is equal to minus 3. I have it to be twice. twice, right? So 2 times I won't find because the same resultant matrix I'll be getting. A minus lambda I into x would be the same resultant matrix. So what I will do, I will in one shot, I'll obtain both the eigenvectors. Let's see how it is. X2 be the eigenvector. For lambda 2 is equal to minus 3, x2 be the eigenvector. Okay. So what I will get is A minus of minus plus 3i. Please be careful. There's a minus sign for the eigenvalue. A minus lambda I. So minus of minus would be plus. Usually students tend to make this mistake, right? This is equal to 0. So I'll add 3 to all the diagonal elements of A. So what I will get, minus 2 plus 3 would be 1. 2 and minus 3. Okay. Yeah. 2 in the diagonal element. 1 is there. 1 plus 3 is 4. Minus 6. Minus 1. Minus 2. 0 plus 3 would be 3. Okay, x2, same thing, x1, x2, x3 be the unknowns in this vector. Y3 because the matrix is a 3 by 3 matrix. Okay, yeah. So, I have to reduce the coefficient, this one to echelon form. So, what I will do, R2 would be what? 2, R2, I'm sorry, R2 plus, no, not plus, R2 minus 2R1. Okay. R2 minus 2R1. What is R3? How will I get a 0 at minus 1 place? R3 would be what? R3 plus R1. Okay. This is a 0. This is a 0. Right? I want a 0 there. So let's see what happens. 1, 2 minus 3. No change in the first row. Second row. I'm multiplying the first row with 2 and subtracting it with the second row. So I'll be having all zeros here. Similarly, I'm adding R3 to R1. So minus 1 plus 1, 0. Minus 2 plus 2, 0. Minus 3 plus minus 3 is also 0. So I have only one equation in the echelon form, or only one non-zero row is there. So what would be the rank of the matrix if one non-zero row is there? Rank is 1. How many unknowns are there? N number of unknowns, x1, x2, x3. 3 unknowns are there. So what I should do? N minus R. That is 3 minus 1, 2 unknowns we will be choosing. 2 unknowns we choose. Okay. So let me write it in equation format. X1 plus 2x2 minus 3x3 is equal to 0 is my equation. Okay. So what I will do? Let x2 is equal to k2 and x3 is equal to k3. Why? Because clearly I know that n minus r unknowns I have to choose. So 2 unknowns I'll be choosing randomly, anything you can choose just to maintain the rhythm, x2 and k2, x3 and k3, because already I've used k1 in the previous eigenvalue, eigenvector. Okay. So what would be x1? X1 is nothing but 3x3 minus 2x2. So 3k3 minus 2k2. Okay. Okay. Now, what would be my eigenvector x2? X2 would look actually like this, 3x3 minus 2x2. X2 is what? K2. X3 is what? K3, which looks very haphazard. So to make it look like a vector, what I will do is I will separate the this is K3, I'm sorry. This is K3 and K2 because X3 is K3, X2 is K2. Okay, so I'll separate the vector. I mean, to make it look like a vector, I'll separate the coefficients of K2 and separate the coefficients of K3. So what I will get, K2 coefficient in the first row is what? Minus 2. K2 coefficient in the second row is 1. No K2 coefficient in the third row. Similarly, K3 coefficient in the first row is 3. In the second row, there is no K3 coefficient. In the third row, the coefficient of K3 is 1. So I have this vector. Now this cannot be called x2, guys. This would be my x2 and this would be my x3. This is for lambda 2 is equal to minus 3. Okay. And then this is for lambda 3 is equal to minus 3. I hope it's clear. Okay. Only if I have, if I can choose two unknowns, I'll be getting the solution. Otherwise, I'll be getting linearly independent vectors. Otherwise, I'll be getting linearly dependent vectors. Okay. I think I'm clear. I will just stop.